Hey everybody, we're going to do another doodle note today. For this assignment, your physics binder, turn to page 20, pencil and a pen. You can color it in if you want to, and you'll need to take a picture with your phone camera to submit it in Schoology. Please pause and get ready for this assignment. Okay, so acceleration is caused by a change in speed, direction, or both. The change in speed might be at the beginning of a drag race. Change in direction might be turning a bus or turning a bike or turning while you're walking. And you could also be both changing your speed and direction, like when you slow down to get off the highway, you turn and slow down. Okay, so the definition for acceleration is the rate of change of velocity. We've got a vector hat because acceleration is a vector quantity. And this change in velocity right here can be shown, as you guys know, with a little triangle to mean change. We can also think of that as change is v2, velocity, the final velocity, minus v1, the initial velocity. It's another way to think about the equation. Velocity is typically in meters per second, could also be in kilometers per hour. Those are the units for velocity. On the bottom here, we have change in time, and that is usually measured in seconds or in hours. Here's another way to rewrite the equation. So here we have a hat for acceleration equals v2 minus v1. That's the change in velocity, divided by t2 minus t1, which is the change in time. And oftentimes we think of this as just a single t. That's fine. You can rewrite it as t. Let's do a quick unit analysis. We did this in class. So the unit for velocity is meters per second, and the unit for time here is seconds. And so when we divide by seconds, it's the same as multiplying here by 1 over seconds. So these two things are the same. And then it's pretty easy to see that seconds times seconds is seconds squared. So the unit for acceleration is meters per second squared. And it's so kind of tricky and important that I put it in this very center of the page. So go ahead and write that there too. As usual, you can pause the video anytime I'm going too fast. All right, let's take a look at these true or false questions. So true or false, acceleration occurs when a bicycle moves consistently in a straight line. Think about it. False. That is no acceleration because there's no change in speed or direction. How about the next one? A raft moves side to side as it floats down the rapids. If it's moving side to side, is there acceleration? Think about it for a second. Yes, so in this case, there is acceleration because direction changes. And then last one, as a car pulls into a parking spot, is it accelerating? Think about it for a second. Yes, so as a car slows down into a parking spot, it is changing its speed, and so therefore it is accelerating. Okay, take a look over here. This is the last example we're going to do. Find the average acceleration of a bus that reaches a top speed of 14.2 meters per second from rest in 22.8 seconds. Because there's no direction, we're going to assume the direction is forward, so that's FWD. Pause the video, write down the variables you know, what you want to know, and which equation you will use. Okay, so hopefully you got those, and that's your equation. Go ahead and pause the video again, plug the values in, and solve the equation. Okay, so hopefully you've got that same answer right there. The acceleration of the bus is 0.623 meters per second squared forward.